Okay, we're going to do some transposition. So I have the formula V is equal to pi r squared h. And I want you to get r on its own. So I want you to get it in terms of r. So what we want is get the r on its own. So let's look at the pi. What's it doing? It's multiplying. So when it comes over, it divides. So V over pi equals r squared h. Now we need to get rid of the h. So when the h is multiplying, so when it comes over, it'll divide. So it's V over pi h equals r squared. And finally, I need to get rid of the squared, so I'll do the opposite of squared. I'll do square root of V over pi h equals r. Okay, second one up then. I've got P is equal to 2L minus 2B, and let's get B on its own. So I'll bring the 2L over, or sorry, I'll bring the minus 2B over, becomes 2B, and I'll bring the P to the other side, TL minus P. Next thing I want B on its own, so the 2 is multiplying the B, so when the 2 comes over, it divides over 2, and that's that done. Okay, then let's say we've got R is equal to P, sorry, pardon me, yes, sorry, R is equal to PV over L, and I want V on its own. So L, we want to get rid of the P and the L, so the L is dividing everything, so when the L comes over, it multiplies, so it's LR equals PV, and the P is multiplying the V, so when it comes over, it will divide LR over P. And normally, this is actually correct, but if we want to just write it correctly at the end, let's just switch it around, so it's V is equal to LR over P. All right. So now we've got one with a fraction. These ones are a bit more difficult. So if I've got 1 over f equals 1 over u plus 1 over v, and I want to get v on its own. All right. Well, the easiest thing to do is to make to combine my fractions on the right-hand side here. So all you're doing to combine fractions is you need a common denominator, and the easiest way to get a common denominator, that means the numbers underneath, is to multiply them. So underneath we do u multiplied by v, uv. Then this multiplies whatever number is here, so v times 1 is v, and u multiplies this number here, u times 1 is u. Okay, we're nearly ready to go. So let's have a look at what we've got here. It's all a bit messed up. I hate fractions. So to get rid of the fractions, we need to get rid of the uv under here and the f under here. So what's the uv doing? It's dividing. So when it comes across, it will multiply. So when uv comes over, it multiplies 1 to give me uv. Now, f here is dividing. So when it comes over, it's going to multiply. So it's f times fv plus fu. Okay. Now, the last thing I want to do is I want to get the v's on their own. So let's bring all the v's to one side. So I'll bring this fv over. uv minus fv equals fu. And finally I want v in its own, so I can factorize v out of this. So that means if v is common, I could write it as v times u minus f. Because when I multiply back in v times u, uv. v times f, fv. So that's equals to fu. And finally, to get v in its own, what's u minus f doing to v? Well, it's multiplying it. So when it comes over, it will divide. That's a tricky one. Okay, that's one of the harder ones. Right, let's see what's next. Okay, so we got q is equal to p minus 3 over p plus 4. So again, I want to get p in its own. So I want to get rid of this whole fraction business anyway. So we look at p plus 4. I don't want anything underneath my line. So what's p plus 4 doing to this? Well, p plus 4 is dividing it. So when it comes across, it multiplies. So it's q times p plus 4 equals p minus 3. Okay, so we multiply that out. We get qp plus 4q equals p minus 3. Now, if we want p in its own, we get all the p's to one side. So that's qp minus p equals minus 4q minus 3. Now lastly, we want p in its own, so p is common to both of these, so I can factorize it out. So it's p times q minus 1. So just remember, how did I do that? Imagine if I multiply this in. P times q, qp. P times minus 1, minus p. Equals minus 4q minus 3. So lastly, to get p in its own, what's q minus 1 doing to p? It's multiplying it, so when it comes over, it'll divide. Minus 3 divided by q minus 1.